When calculating residential load for a single-family dwelling, the National Electrical Code requires that the service entrance conductors be sized for the maximum load that the service can supply. However, the National Electrical Code also allows for load diversity. Load diversity recognizes the fact that not all electrical loads in a dwelling operate simultaneously at their maximum demand. The National Electrical Code Table 220.82 provides a demand factor of 80% for dwelling units equipped with more than one electric range. This provision allows for sizing the service entrance conductors at 80% of the calculated total load. In situations where a calculated load slightly exceeds 400 amps with load diversity already considered and applying the 80% rule reduces the load below 400 amps, this approach is acceptable under the National Electrical Code guidelines. The service entrance conductors can be sized based on the reduced load calculated at 80%, which in this example would be 320 amps. It's crucial to understand that the 80% rule specifically applies to dwelling units with more than one electric range. If a dwelling unit has only one electric range, the service entrance conductors must be sized to accommodate 100% of the calculated load without applying the 80% demand factor. Failing to properly calculate electrical loads and apply appropriate demand factors can lead to undersized service entrance conductors, which may result in overheating, voltage drops, and potentially hazardous conditions. It is important to consider all applicable loads when performing residential electrical load calculations, including general lighting and receptacle circuits, appliance circuits, electric ranges or ovens, water heaters, heating and air conditioning systems, and any other significant electrical loads within the dwelling. The National Electrical Code provides specific guidelines and tables for calculating the demand load for each of these types of loads. These calculations typically involve applying demand factors that account for the fact that not all of these loads will be operating at their maximum demand simultaneously. General lighting and receptacle circuits are typically calculated based on a minimum load per square foot of floor area. Appliance circuits are calculated based on the rating of the appliances they serve. Electric ranges and ovens are calculated based on their nameplate ratings, with demand factors applied based on the number of ranges or ovens present. Water heaters are calculated based on their nameplate ratings. Heating and air conditioning systems are calculated based on their nameplate ratings, with demand factors applied based on the type of system and the climate in which the dwelling is located. Once the demand load for each type of load has been calculated, these individual loads are summed to determine the total calculated load for the dwelling. This total calculated load is then used to size the service entrance conductors, taking into account any applicable demand factors such as the 80% rule for dwelling units with more than one electric range. The National Electrical Code contains numerous tables and examples to guide electrical professionals in accurately calculating residential electrical loads and selecting appropriately sized service entrance conductors. Consulting the National Electrical Code and seeking guidance from experienced electrical professionals are essential steps in ensuring the safety and reliability of residential electrical systems. The 80% rule is a specific application of demand factors outlined in the National Electrical Code. Demand factors account for the diversity of electrical loads within a building. Electrical codes provide requirements for calculating the minimum size of electrical services and feeders based on the expected load. These calculations ensure that the electrical system can safely and reliably supply power to all connected loads. The 80% rule, as mentioned, applies to dwelling units with multiple electric ranges. This is because it is unlikely that both ranges will be used at their maximum capacity simultaneously. By applying the 80% demand factor, the calculated load is reduced, allowing for smaller service entrance conductors. It is important to note that the 80% rule is not a blanket reduction for all residential loads. It specifically applies to the demand load calculation for electric ranges when there are more than one. Other loads, such as lighting, receptacles, and appliances, have their own demand factors or are calculated at 100%. When performing residential load calculations, it is crucial to follow the procedures outlined in the National Electrical Code. These procedures involve determining the connected load for each type of electrical equipment and then applying the appropriate demand factors. The demand factors are based on statistical data and engineering judgment and are intended to reflect the actual load that is likely to be present in the electrical system. The National Electrical Code provides tables that list the demand factors for various types of electrical equipment. These tables are essential for accurate load calculations. It is important to use the correct demand factors for the specific equipment being installed. In addition to demand factors, the National Electrical Code also provides guidelines for calculating the load for specific types of equipment, such as electric ranges, water heaters, and air conditioners. These guidelines take into account the operating characteristics of the equipment and the potential for simultaneous operation. For example, the National Electrical Code provides a method for calculating the load for electric ranges based on the nameplate rating and the number of ranges present. The National Electrical Code also provides guidelines for calculating the load for air conditioners based on their cooling capacity and the climate in which they are installed. Once the load for each type of equipment has been calculated, the total calculated load is determined by summing the individual loads. This total calculated load is then used to size the service entrance conductors and other electrical equipment. It is important to ensure that the service entrance conductors and other electrical equipment are sized to safely carry the total calculated load. Undersized conductors can overheat and cause a fire hazard. Oversized conductors are more expensive and may not be necessary. The National Electrical Code provides tables that list the ampacity of various sizes of conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry. It is important to select conductors with an ampacity that is equal to or greater than the total calculated load. In addition to conductor ampacity, it is also important to consider the voltage drop in the conductors. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause electrical equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to a maximum of 3% for feeders and 5% for branch circuits. The voltage drop in a conductor depends on the length of the conductor, the amount of current flowing through the conductor, and the resistance of the conductor. The National Electrical Code provides formulas for calculating voltage drop. When performing residential load calculations, it is important to consider all of the factors that can affect the load in the electrical system. These factors include the size of the dwelling, the number of occupants, the types of appliances and equipment that will be used, and the climate in which the dwelling is located. By carefully considering all of these factors, it is possible to accurately calculate the load in the electrical system and ensure that the service entrance conductors and other electrical equipment are sized appropriately. The 80% rule is just one aspect of residential load calculations. It is important to understand all of the applicable requirements in the National Electrical Code in order to ensure the safety and reliability of the electrical system. The National Electrical Code is a complex document, and it is important to consult with a qualified electrical professional if you have any questions or concerns. A qualified electrical professional can help you to accurately calculate the load on the electrical system and select the appropriate size of service entrance conductors and other electrical equipment. They can also help you to ensure that the electrical system is installed in accordance with the National Electrical Code and other applicable codes and standards. Remember, the 80% rule applies to dwelling units with more than one electric range. If the dwelling unit has only one electric range, the service entrance conductors must be sized for 100% of the calculated load. The National Electrical Code provides specific guidelines and tables for calculating the demand load for various types of loads, including general lighting, receptacle circuits, appliance circuits, electric ranges, water heaters, and heating and air conditioning systems. The National Electrical Code is updated regularly to reflect changes in technology and safety standards. It is important to stay up to date in the latest edition of the National Electrical Code in order to ensure that your electrical work is in compliance with current regulations. Consider continuous load calculations. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. Branch circuit conductors and overcurrent protection devices for continuous loads are required to be rated at 125% of the continuous load. This requirement is intended to prevent overheating of conductors and overcurrent protection devices due to prolonged high current flow. The National Electrical Code Section 210.19, A1 and 210.20 address the minimum conductor and overcurrent device ratings. Understanding conductor ampacity is crucial. Conductor ampacity refers to the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is affected by several factors, including the conductor material, size, insulation type, installation method, and ambient temperature. The National Electrical Code provides tables that list the ampacities of various types of conductors under different conditions. These tables are essential for selecting the correct size of conductors for a particular application. The ampacity of a conductor must be equal to or greater than the non-continuous load plus 125% of the continuous loads. Correctly calculating and applying demand factors and considering continuous loads are essential for ensuring the safety and reliability of residential electrical systems. Ignoring these factors can lead to undersized conductors, overloaded circuits, and potentially hazardous conditions. Always consult the latest edition of the National Electrical Code and seek guidance from qualified electrical professionals when designing or installing residential electrical systems. Remember to also consider future expansion. When designing a residential electrical system, it is important to consider the potential for future expansion. As families grow and lifestyles change, the demand for electricity may increase. It is therefore advisable to install a service entrance and panel board with sufficient capacity to accommodate future loads. This can help to avoid the need for costly upgrades in the future. The National Electrical Code provides guidelines for calculating the size of the service entrance and panel board based on the expected future load. These guidelines take into account factors such as the size of the dwelling, the number of occupants, and the types of appliances and equipment that may be used in the future. By planning for future expansion, you can ensure that the electrical system will be able to meet the needs of the household for many years to come. Another important consideration is the location of the service entrance and panel board. The service entrance should be located in a readily accessible location, and the panel board should be located in a central location within the dwelling. This will make it easier to access and maintain the electrical system in the future. The panel board should also be located in a dry and well-ventilated area to prevent corrosion and overheating. Additionally, consider energy efficiency. When designing a residential electrical system, it is important to consider energy efficiency. Energy-efficient appliances and lighting can help to reduce energy consumption and lower utility bills. The National Electrical Code encourages the use of energy-efficient products and practices. There are several ways to improve the energy efficiency of a residential electrical system. These include using energy-efficient appliances, installing energy-efficient lighting, and using occupancy sensors to control lighting in infrequently used areas. You can also reduce energy consumption by using timers to control water heaters and other appliances, and by installing a programmable thermostat to control the heating and air conditioning system. By implementing energy-efficient measures, you can save money on your utility bills and reduce your environmental impact. Be aware of local codes and regulations. In addition to the National Electrical Code, there may be local codes and regulations that apply to residential electrical systems. These local codes and regulations may be more stringent than the National Electrical Code. It is important to be aware of all applicable codes and regulations before beginning any electrical work. The local building department can provide information on local codes and regulations. It is also advisable to consult with a qualified electrical professional to ensure that your electrical work is in compliance with all applicable codes and regulations. Proper grounding and bonding are essential for safety. Grounding and bonding are essential for protecting people and equipment from electrical shock. The grounding system provides a path for fault current to flow back to the source, which causes the overcurrent protection device to trip and to energize the circuit. The bonding system connects all metal parts of the electrical system together, which prevents voltage differences from occurring between them. The National Electrical Code provides detailed requirements for grounding and bonding. These requirements must be followed carefully to ensure the safety of the electrical system. A qualified electrical professional can help you to design and install a proper grounding and bonding system. Always use approved materials and equipment. It is important to use only approved materials and equipment when working on a residential electrical system. Approved materials and equipment have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories. Approved materials and equipment are designed to meet specific safety standards. Using unapproved materials and equipment can create a fire hazard or electrical shock hazard. The National Electrical Code requires the use of approved materials and equipment. When purchasing electrical materials and equipment, look for the UL listing mark or other recognized testing laboratory mark. This mark indicates that the material or equipment has been tested and certified to meet safety standards. Always disconnect power before working on electrical circuits. Always disconnect power before working on electrical circuits. This is the most important safety precaution that you can take. Disconnecting power prevents the possibility of electrical shock. Before disconnecting power, use a voltage tester to verify that the circuit is de-energized. The voltage tester should indicate 0 volts. After disconnecting power, lock out and tag the circuit breaker or fuse to prevent someone from accidentally re-energizing the circuit. Never work on electrical circuits while they are energized. This is extremely dangerous and can result in serious injury or death. Take your time and be careful. Electrical work can be dangerous if not done properly. Take your time and be careful when working on electrical circuits. If you are not comfortable performing a particular task, hire a qualified electrical professional. A qualified electrical professional has the knowledge and experience to perform electrical work safely and correctly. They can also help you to ensure that your electrical system is in compliance with all applicable codes and regulations. Remember safety first. Always prioritize safety when working on electrical circuits. By following these safety tips, you can reduce the risk of electrical shock and other hazards. If you are not comfortable performing electrical work, hire a qualified electrical professional. In summary, understanding the 80% rule, applying appropriate demand factors, considering continuous loads, planning for future expansion, and following all applicable codes and regulations are essential for designing and installing safe and reliable residential electrical systems. Always consult with qualified electrical professionals and prioritize safety when working with electricity.